Okay, so we're going to look at surds and I suppose primarily surd equations because that's kind of completely new and that's kind of more the thing that we really need to work on. We're going to look quickly at kind of our surd rules, running quickly through those ideas and getting into maybe some of the ones that we don't know, so like rationalizing the denominator and things like that. So quickly running through the stuff that I suppose we should know at this stage. So a surd is a root which cannot be reduced to a rational number. So like the square root of 2. The square root of 2 can't be reduced to any other sort of rational number, so a fraction or a non-recurring kind of, or not kind of simple decimal, I suppose. So root 2 is considered the exact answer, and if we converted that to a decimal, we would have to round our decimal so we get what we consider an approximation. So like we can see here, if we do root 2, we get 1.414 and so on and so forth, and even my calculator there is rounding off its answer at the end, but that's only an approximation of the result of root 2. As I've said, there's a number of surd operations we have to be familiar with. Our calculator does a lot of these, but we should know the rules ourselves. And they are kind of all stemming from our indice rules as well, kind of bearing in mind what we know about a square root being the same as having something to the power of a half. A lot of the rules kind of follow from that idea, so following from our indice rules. So for example, quick first rule, when we're multiplying surds, we use the following rule. So we multiply what is inside the surds. So if we have root 10 times root 13, we're going to be multiplying the 10 by the 13, and we can get the square root of 130. Same thing goes for the next one, square root of 140, square root of 400. Okay, square root of 400 obviously gives me 20. Okay, some of these can reduce then, some of them can't. Okay. But moving on from our multiplying, then I suppose we're looking at reducing surds to lowest form. And again, if we type these into our calculator will do a lot of these for us, but we should be able to do them ourselves. It's kind of important that we have that ability as well. So when we're reducing surds, what we try and do is to rewrite the given surds, whatever's under the square root, in terms of its factors, but particularly we're looking for the highest square number that is a factor of whatever's under the square root. And if we can't find the highest one, we can go with a lower, just remembering that there could be a second one for us to go with. So looking at the square root of 200, we could rewrite that, for example, as 2 times 100. Using my square root rules, now the one that we just saw, I can resplit that up now to be square root of 2 times square root of 100. So it's kind of the opposite of the rule we had previously. Square root of 2 does not simplify, but square root of 100 is of course just 10. So I get 10 root 2 as my answer there. Okay, 10 root 2. Looking at the next example, then I have square root of 450. So I can rewrite that as the square root of 225 times the square root of 2 times 2. So square root of 225 times root 2, you see, and reducing that down, that gives me 15 times root 2, which is 15 root 2. Okay, lastly, 375, I can rewrite that as 15 times 25, which is root 15 times root 25, which is 5 root 15. Okay, so again, just reducing these things down. As I say, your calculator will do that and you can use it to check, but you should know the rules for yourselves. When it comes to adding and subtracting surds, we kind of think in the same way as algebra. So we can add things that have the same square root part. So for example, here, if I have two terms that have a root b, if I add them together, I can add the kind of coefficients of that. And similarly, if I have two parts with the same surd component, I can subtract those also. And the kind of only other extra part to be aware of is in order to use this, sometimes we may have to reduce the surds as we did in those previous examples there. So looking at the first example, fairly straightforward. I get 8 root 2 minus 3 root 2, which of course is 5 root 2. In the second example, then I need to reduce my surds before I'm able to simplify. So 48, let's just see and show how our calculator would reduce these for us. Square root of 48 is 4 root 3. Square root of 27 is going to be 3 root 3. And the square root of 12 is going to be 2 root 3. So putting that all together gives me 5 root 3. So just to see how our calculator can reduce these for us as well. When we're expanding surd equations, or surd expressions here, same thing kind of factors in, okay? The only extra part is just to be aware of when we have to simplify these surd expressions, that we can use these ideas that we've been coming across. So if I'm multiplying this out, 4 by 3 gives me 12. 4 multiplied by the 7 root 5 will give me 28 root 5, minus 6 root 5, and minus 14, and root 5 by root 5 will just give me 5 overall. So I get 12 minus 22 root 5 minus 70, which of course gives me minus 58 minus 22, or plus 22 root 5, excuse me, plus 22 root 5. Okay, and that's just same idea again, just making use of those different rules that we have. So let's see, one of the last kind of rules we have here before we get into the kind of new parts is just simplifying quotients. Again, this comes back to those indice rules I was talking about earlier. If I have a square root over a fraction, I can split that up so that it's square roots for both parts of the fraction. So a square root of an overall fraction is the same as having the square root of the numerator over the square root of the denominator. And again, this can just help us to simplify things down. So square root of 16 over 81 is the same as square root of 16 over square root of 81, which is 4 over 9, which actually can't reduce down any further. Looking at the next example, that's root 50 over root 36, which if I type into my calculator, root 50 will reduce down to 5 root 2, and root 36 is of course just 6. So I get 5 over root 2, 5 root 2 over 6. Lastly, root 8 over root 50. Well, we know what root 50 is. Square root of 8 we might know as well, 2 root 2 over 5 root 2, which of course just roots down to 2 over 5 by dividing the root 2 into the top and the bottom there. So same idea again, and really it's just important that you're aware of all these rules, and a lot of these rules shouldn't be new to you. Okay, we're coming to one now that I would consider to be new, and that's what we call rationalizing the denominator. So we're going to spend a little bit more time on this one. So rationalizing the denominator is a method that we use when we're dividing by surd expressions. And when we're working with fractions, and if we have a fraction where we have a surd in the bottom, we typically don't want that. We don't like to leave surds in the bottom. We're okay with having them in the numerator, and that's really all that or the only place we want to have them. So what we do is we rationalize the denominator. And remember that rational in terms of our numbers, rational just means it's written as a fraction. Okay, so rational just means it can be written as a fraction. So we want to kind of make the bottom part have no surds. Okay, so really we're just eliminating surds. And the way that we do this kind of depends a little bit on how many surds I have. So we either have one surd in the denominator, or we have an expression with surds in the denominator. And how we handle them kind of depends on which we have. If we have one surd in the denominator, the easiest way to get rid of a surd, to get rid of a root, is just to multiply by that same root. So if we think about it, by definition, if I have the square root of 3, if I multiply that by the square root of 3, that's going to give me 3, because this expression here is the same as having the square root of 3 squared. And of course those are inverse operations. So if I have the square root of 3 and I square it, then I just end up with 3. So if I only have one surd on the bottom, the easiest way that I can get rid of that is to simply multiply by that surd itself. The other thing we need to just be aware of is just to then simplify any further simplification that we can make. So looking at this first example here, I have 6 root 3. I'm going to multiply by root 3. I get 6 root 3 over 3, which will of course reduce down to 2 root 3. Okay, continuing on here now, the same idea applies here. I have 2 root 2 and I have root 3 on the top. So what I'm going to do is I'm going to multiply by the entire term that I have on the bottom here. So I'm going to multiply by the 2 root 2 that I have on the bottom. So that's going to give me 2 root 6. So multiplying the root 3 by the root 2 gives me root 6. And on the bottom, 4 by 2. And that's going to give me root 6 over 4 overall. Okay, root 6 over 4. Let's continue on with the last expression here, and we're just going to see the slight, I suppose, difference that we could make here is if we wanted to, we could just multiply by the root 7. So I get 8 root 7 over 3 times 7, which is 8 root 7 over 21. So if we wanted to, we could just multiply by the surd itself and not the entire term, but it's no harm just to get into the practice of multiplying by the entire term either. So let's just look at the expression with the surd in the denominator. So if we have an expression with the surd in the denominator, we have to find what we call the conjugate of the denominator. And the conjugate of the denominator is essentially the same expression, but with the sign changed in the middle. Okay, the sign between, we change the sign between the terms. Okay, so if the denominator is 3 plus root 5, the conjugate's 3 minus root 5. If it's 6 minus root 7, the conjugate is 6 plus root 7. Okay, the idea here is that by multiplying these expressions, we're going to be able to eliminate the surd part of the expression. So we multiply the numerator and the denominator by the conjugate to eliminate the surds. And that's important as well. It has to be both numerator and denominator. And that's just our usual rules. We can't multiply part of a fraction. We have to multiply both sides, both the top and the bottom of the fraction. So let's have a look at the first example here. So I have root 5 minus 2 on the bottom. So taking that expression there, the conjugate is going to be root 5 plus 2 and root 5 minus 2. Or not root 5 minus 2, what am I saying? Root 5 plus 2. The conjugate is root 5 plus 2. So we're multiplying both the top and the bottom by that conjugate. So multiplying the top part just gives me root 5 plus 2. Fairly straightforward. For multiplying the bottom part, we just have to be careful. The root 5 by root 5 will give me 5. Root 5 by plus 2 gives me 2 root 5. By the minus 2 gives me minus 2 root 5, and I get minus 4 at the end. So I get root 5 plus 2 all over 5 minus 4, which of course is just 1. So I get root 5 plus 2. And if we want to, this is the sort of question that we can double check on our calculator, but in an exam or in a test or something like that, we would need to show the steps that we're following. We need to be able to do this without just typing it into our calculator. And it is one that you can't really work backwards from. You need to know what the steps are. But we can see that by checking in our calculator, we just get to verify our answer that way. Looking at the next one then, again, same as before, I need to multiply the top and the bottom by the conjugate of the bottom part. A little bit more complicated this time because I have a full surd expression on the top, but again, I just change the sign between them. I'm going to multiply out the top part first, so 10 plus 2 root 3 minus 5 root 3 minus 3. And on the bottom, 25 plus 5 root 3 minus 5 root 3 minus 3 again. So that gives me 7 minus 3 root 3 all over 25 minus 3, which is 7 minus 3 root 3 over 22. Same idea again, and we have rationalized that to the fullest extent there. Okay, so the idea, again, as we've said, of rationalizing is just to remove surds from the bottom. We're allowed to still have surds in the numerator part. Okay, lastly, we have, again, just getting slightly more complicated or more advanced as we continue on here. So 2 root 7 plus 3 root 3 and 2 root 7 plus, or sorry, I'm taking the wrong part there. Remember, it's the bottom part that we get the conjugate of. Doing too many things at once here. Okay, so that's the idea. So we're multiplying the top and the bottom of my expression by the conjugate of the bottom part. So it was plus in between the terms, so now we make it a negative, we make it a minus. So I have to be careful multiplying all of this out because I can see immediately there's a lot of moving parts. So the 2 root 7 by 5 root 3, I get 10 from the 2 by 5, and I get root 21 by the square roots there. Minus 8 by 7, minus 15 by 3, and plus 12 root 21. On the bottom, 25 by 3, minus 20 root 21, plus 20 root 21, minus 16 by 7. Okay, so we have a lot of different parts to work out here, so let me get my calculator ready. So 10 root 21 plus 12 root 21 gives me 21 root 21. Okay, I can't do an awful lot with that part. 8 times 7, okay, again, don't mind checking that on my calculator. 56, 15 times 3, again, 45. Okay, and we'll simplify that down as well. On the bottom here, 25 by 3, of course, 75. The middle parts will eliminate each other. So minus 20 root 21, or minus 20 root 21 plus 20 root 21, that's just going to go away, which is the idea. And 16 times 7 is minus 112, minus 112. So we now have, let me see, 56 plus 45, 101. So 21 root 21 minus 101 all over 75 minus 112, which is minus 37. Now, we can leave our answer like that, although I would generally say we don't always like to have a negative number on the bottom. So if you want, you can kind of multiply both parts here by a minus 1, by a negative 1. And all that that's going to do is it's just going to change the order and sign of each of these parts on the top of my expression there. But we end up with the same idea the whole way through. Okay, the same idea the whole way through. So that should be 22. That should be 22. So 101 minus 22 root 21 all over 37. Okay, so the idea follows the same way no matter what we're doing. We just need to make sure that we are rationalizing the denominator fully, and then that we are being careful with the calculations there, because as you can see, it's very easy to make a mistake in those calculations, even kind of the simple ones there. So even though, yes, I'm pulling out the calculator for some of the easier parts, sometimes it is no harm. So let's just quickly run through these practice questions, I suppose, that are in the booklet for you to work through. So root 3 minus 7 over root 3 plus 7, same idea again. We just multiply by the conjugate of the bottom part, which is going to be root 3 minus 7. It's going to be 3 minus 7 root 3 minus 7 root 3 plus 49 all over 3 minus 7 root 3 plus 7 root 3 minus 49. So that's going to give me a total answer of 52 minus 14 root 3 all over minus 46, all over minus 46. And I can then swap the order of my terms there. 14 root 3 minus 52 all over 46. Okay, same as we did before, multiplying top and bottom, minus 1. Okay, let's look at the next little part. Same idea again, even though, yes, our expression on the top is not as long as the one at the bottom, it doesn't change our method. Okay, it's still conjugate of the bottom part. It's just changing the sign on the inside. Multiplying those out now, 5 root 2 by root 2 is 5 by 2 plus 5 root 2. The bottom part now, 2 plus root 2 minus root 2 minus 1. So I get 10 plus 5 root 2 all over 1, which of course is just 10 plus 5 root 2. Okay, and you can kind of see, like, as you get into doing these, you do kind of just get into the swing of them, but it's very important that you're able to follow those steps. And changing the sign in between those there to get the conjugate of the bottom part. And then we're just following through with some multiplication as we've done with all the other ones. So 6 root 11 minus 10 minus 3 times 11 plus 5 root 11 all over 9 times 11 minus 15 root 11 plus 15 root 11 minus 25. So simplifying all this down again as best we can, 11 root 11 minus 10 minus 33 all over 99 minus 25. So I get 11 root 11 minus 43 all over 99 minus 25 is going to give me 74. 74, okay? So the main thing to prioritize here is just this last section, is rationalizing the denominator. Making sure that you know, particularly for these ones with the expression, with the surds in the denominator, that you're able to rationalize in that way. Getting the conjugate of the bottom part, multiplying top and bottom by that, and using that to reduce your surds down. As we've said, you can always verify with your calculator, but you need to be able to show the steps that you're working through there. So that's kind of your main surd rules. As I said, we're going to prioritize the surd equations, so we're going to do that in the next video then. So we're going to look more at the surd equations and how we approach those in the next video.